When most people picture an airplane, they imagine massive jet engines, sweeping wings, or a cockpit packed with cutting-edge technology. Almost nobody thinks about the wheels. But when it matters most, during landing, those wheels take the hit. A commercial airliner can slam onto the runway at speeds exceeding 155 miles per hour, carrying the weight of hundreds of tons. In just a few seconds, all that momentum has to be absorbed. And the very first thing to make contact with the pavement isn't the wings or the engines, it's the tires. There's no guesswork in this part of the aircraft. Every wheel is engineered to handle crushing loads, extreme heat, and sudden bursts of speed. These aren't just oversized car tires. They're highly certified aviation components, rigorously tested in specialized facilities and constantly monitored by airlines. If there's one component that absolutely cannot fail at the most critical moment of flight, it's this one. And once you understand how these wheels actually work, you start to see air travel in a completely different way. So to understand what makes them so extraordinary, we have to begin where the real stress begins, the exact instant of touchdown. The toughest moment for an aircraft's wheels happens in a split second, the instant the plane meets the runway. Before touchdown, those wheels aren't spinning. They're essentially still. The moment they hit the pavement, they have to jump from 0 to well over 120 miles per hour almost instantly. That sudden acceleration creates intense friction, which is why you often see a brief puff of white smoke right as the tires make contact. But speed is only part of the story. A large jet can land weighing 700,000 to 900,000 pounds, and that enormous mass is transferred directly into the landing gear. The force isn't just straight down. As the aircraft begins to slow, powerful forward and sideways forces come into play as well. The tires and the entire landing gear assembly must absorb all of it, without buckling, warping, or losing stability. Every single landing is a serious stress test. And that leads to a question many people naturally ask: with that much speed and weight involved, why don't the tires just burst? The answer lies in how they are built. Aircraft tires are nothing like the ones on your car. Inside, they contain multiple layers of high-strength reinforcement made from industrial-grade nylon and aramid fibers, the same family of materials used in bullet-resistant gear. These layers create a tightly engineered internal framework capable of handling tremendous loads without tearing or deforming. This isn't just thick rubber wrapped around a wheel. It's structural engineering in motion. And that brings us to another critical factor: internal pressure. A typical car tire runs at around 30 to 35 psi. An airliner tire? Close to 200 psi. That's roughly 6 times the pressure of your vehicle's tires. That extreme pressure is critical. It helps the tire maintain its shape under brutal impact loads, preventing excessive flexing when hundreds of thousands of pounds hit the runway. The rigidity created by that pressure is part of what keeps everything stable during touchdown. But it doesn't stop there. Before these tires are ever installed on an aircraft, they go through intense certification testing. We're talking about high-speed spin tests, maximum load landing simulations, and stress conditions that go well beyond what they'll normally experience in service. They're engineered with a safety margin because landing is not a moment where anything can go wrong. And there's another safety detail most people never hear about. Aircraft tires aren't filled with regular air. They're inflated with dry nitrogen. That choice isn't about convenience or branding, it's about safety. The air we breathe contains oxygen and moisture. In a landing scenario, where braking can generate extreme heat, oxygen and water vapor inside a tire can cause unpredictable pressure changes and increase certain risks. Nitrogen, on the other hand, is inert and dry. It doesn't easily react, it minimizes internal corrosion, and it eliminates moisture inside the tire. Yes, nitrogen expands when heated, just like any gas, but without water vapor mixed in, that expansion becomes far more stable and predictable. And in aviation, predictability is everything. When temperature and pressure can change rapidly within seconds, control matters. That's why nitrogen inflation has become standard practice in commercial aviation. Now you understand the balance of strength and control that keeps these wheels performing under extreme conditions. Now take a closer look at a large jet sitting on the ramp and another question comes up. Why does it need so many wheels? If you've ever seen a wide-body aircraft up close, you've probably noticed the sheer number of tires underneath it. A Boeing 747, for example, rolls on 18 tires. The massive Antonov An-225, the largest aircraft ever built, used 32. That's not overkill. It's engineering. A fully loaded airliner can touch down weighing 600,000 to 900,000 pounds, or more. If that entire load were supported by just a handful of wheels, the stress on both the landing gear and the runway would be extreme. By spreading the weight across many tires, engineers dramatically reduce the load each one carries and lower the pressure applied to the pavement. That protects the aircraft. And it protects the runway. But it's not only about weight distribution. Multiple wheels also improve stability during touchdown and braking. At high speeds, balance and directional control are just as important as strength. More contact points with the runway mean better control when it matters most. And then comes the question everyone thinks about, but hopes never happens. What if a tire blows during landing? While tire failures are rare, aircraft are designed with that possibility in mind. Certification standards require that a plane must be able to land safely even if one tire fails. The system doesn't rely on a single wheel. The load is shared across multiple tires, and the landing gear structure is built to handle temporary imbalances and shock loads without losing stability. In aviation, safety isn't based on luck. It's built on redundancy. Unlike car tires, aircraft tires aren't designed to shred or explode under stress. They're heavily reinforced to prevent sudden, catastrophic rupture. Even if damage occurs, the tire structure is built to hold together long enough for the aircraft to slow down and come to a controlled stop. There have been real-world cases where planes landed with compromised tires and still maintained full stability during rollout. That's not luck, that's intentional engineering. Aviation safety is built on layers of backup systems and careful planning. But the wheel's job doesn't end when the plane touches down. In many ways, the hardest part is just beginning. Once the aircraft is on the runway, the next major challenge is slowing it down. The wheels don't just carry the weight, they play a critical role in stopping the airplane. Modern commercial jets use carbon brakes, which are capable of handling extreme heat, often exceeding 1,800 degrees Fahrenheit. That's necessary because bringing hundreds of thousands of pounds down from highway speeds generates an enormous amount of energy. Still, braking isn't handled by the wheels alone. Right after touchdown, spoilers deploy on top of the wings. Their job is to dump lift, forcing more of the aircraft's weight onto the landing gear. More weight on the wheels means better traction and more effective braking. At the same time, thrust reversers redirect engine power forward, helping slow the aircraft down even faster. It's a coordinated system, tires gripping the runway, carbon brakes absorbing heat, wings killing lift, and engines pushing against forward motion, all working together to bring a massive jet safely to a stop within the length of a runway. And beyond the engineering, there's another side to this story, one airlines understand very well. Cost and maintenance. Because managing aircraft tires isn't just about swapping them out when something goes wrong. They're not cheap, but they're not outrageously priced either, like many people assume. For large commercial jets, a single tire can cost several $1,000s, depending on the aircraft type and manufacturer. But the real story isn't the sticker price. It's the maintenance strategy behind them. Aircraft tires are designed to be retreaded multiple times. The main casing is carefully inspected, reused, and fitted with a brand new tread layer. This process significantly reduces costs while still meeting strict aviation safety standards. And replacements aren't based on guesswork. Tires are removed according to clearly defined technical limits, based on detailed inspections, the number of landing cycles, and measurable wear. Airlines track every tire with precision. Nothing is left to chance, and nothing is decided at the last minute. In the end, those wheels most passengers barely notice while boarding are actually among the most heavily tested and closely monitored components on the entire aircraft. They may look small compared to the size of the plane, but every safe landing you've ever experienced depended on them. Thanks for watching all the way through. If you enjoyed this breakdown, make sure to subscribe, hit the like button, and turn on notifications so you don't miss the next deep dive into how aviation really works.